We live in a very exciting time. Today, the digital transformation is bringing us to a new paradigm where the physical world and all the world's digital data converges. This quote by Arthur C. Clarke sums up our experience with advanced innovation. Any sufficient advanced technology is indistinguishable from magic. Technology continues to move at an exponential pace, merging the real world we live in with the digital twin, the virtual world, linked by the Internet of Things, the data about the world, then leveraging machine learning and artificial intelligence. All of this provides the magical platform for the future. Every day we are amazed with the innovations we see, connecting us to each other with information limited only by our imagination. Now let's start today's journey by understanding what we mean by a digital twin. We define a digital twin as a synchronized virtual representation of a real-world asset, a digital version of reality that is continuously updated. Now you might be asking yourself, why is this important to me, or what does it really mean? Or maybe, what can I do that I couldn't do before? For starters, I want you to think about the Uber app on your phone. It's easy to use, provides real-time data, and gets you where you need to go. It's hassle-free and interface is easy to use. The need to get from A to B never changed. What changed was the entire transactional experience. When it comes to digital twins, we're taking a similar approach. We believe that interacting with the digital version of real infrastructure should be easy, intuitive, and deliver contextual, relevant information when and where our users need it. How the users transact with their information is shifting. We are seeing owners, designers, contractors, and users throughout the supply chain embracing this new way of working. We're talking about true digital evolution and how the physical environment and its real-world infrastructure, including all of the equipment, materials, labor, sensor data, and related information, is managed throughout the life cycle. A digital twin includes the 3D geometry, design information, documents, issues, photographs, and point clouds, the full history of the asset as it changed over time. This includes the prototyping phase, the construction phase, the operations, the maintenance, and any subsequent redesign. So what does this mean to you? It means that you can now access, update, and most importantly, respond to information about your asset using an intuitive user interface design for web, mobile, and mixed reality. So how is a digital twin different from BIM, Building Information Modeling? That's a fair question. The way we see it is digital twin is a non-disruptive evolution of BIM-centered workflows. It's a shift from static models to dynamic models, from files to change ledgers, from desktop applications to web apps, from 2D touch screens to interactive 3D holograms. Digital twins advance existing model-based processes by optimizing the feedback loop between team members, using modern, accessible user experiences backed by cloud services. The virtual and physical are converging, creating tighter and tighter feedback loops. And that is what leading organizations are getting out of digital twins. Tighter feedback loops leading to better decisions, making better improvements in workflow productivity, human safety, and asset reliability. So for an example, when a field engineer updates status on a concrete column being erected in the field, that information is reflected in the construction digital twin, and the project schedule gets updated. Likewise, when a sensor on a pump at a substation detects a problem, that information is conveyed to an engineer wearing a head-mounted holographic display. And for a bridge inspector, he can now use a drone capture with machine learning to automatically visualize defects on the bridge in an immersive 3D experience, allowing the bridge inspection to be done from anywhere. For the general public and citizens and residents in a city, they and the infrastructure that supports the city can be visualized and updated in near real-time interaction. To talk about the impact of digital twins on city-scale infrastructure, Let me introduce Sanjeev Shah to discuss the HS2 project, Europe's largest infrastructure project, and how the city of Helsinki is using digital twins today. So, Sanji, please walk us through the ways HS2 and the city of Helsinki are using and managing their digital assets through digital twins.
High Speed 2 is Europe's largest infrastructure project. But even still, they shared the same problems that many of you will be facing today. They use many specialist systems which create specialist content which is stored in specialist systems. So for a user to get to all of that information, they'd have to be proficient in each of those systems, they'd need licenses for each of those systems, and that can be expensive. It can be prone to duplication errors. It will create waste. It will lead to litigation and issues, and we don't want that to happen to you. What we're seeing, however, and what our users are telling us, is that by far the easiest way to get to content is through a geographical user interface. So here we can see through a quick zoom and a single click, we get instant access to a whole myriad of information. And it doesn't matter if that information in the top left portlet has come from High Speed 2's asset information database, or whether the information we're seeing from models and from the documents has come from AssetWise and soon to be ProjectWise. The maps we're seeing is a direct federation from Esri ArcGIS. But what if you wanted to get into models and see things at detail? Yes, you can just click on the models and they will open up, whether that's in a browser, a mobile phone or a tablet. And it doesn't matter if those models were created in specialist systems such as Revit or MicroStation or Navisworks, you'll still be able to view the whole lot. Well, here in Highways England Smart Motorways Digital Twin, we've just done just that. We've zoomed in from macro to micro. In this case, a design engineer has isolated a traffic monitor camera. It could have been a bridge, and they could have looked at the details of what the construction methodology was. They could have looked at the date that bridge was constructed, and they might have wanted to then zoom out and see all other bridges that were using the same construction methodology, installed at the same date, and that's exactly what we've done here. So on the right hand side, we zoom out, we can see lots of these cameras appear, a bit like TripAdvisor. What you see in your screen is what it's going to list on the left hand side. So that is now going from micro to macro. So yes, we can do this at scale, as we've just seen. City of Stockholm are using digital twins. They're using digital twins to provide a better experience for their citizens. So by bringing in flood data, information about the population, crime information, all sorts of external information combined to the spatial geometry, the data, the documentation, that is building a full digital twin. But that data need not just be from sensors, for example. If we look at this example here, we can see a project in West London, and would you be amazed if I said these yellow circles are actually representing physical movements in infrastructure up to 1 millimeter. And would you be amazed if I said we've got no sensors installed here? All of that data is being captured from space, from satellites. So we can actually see the performance of infrastructure in places where we didn't even know we needed to monitor that. And what's even better is all of this data is being captured continuously. So we can now go and tap into that information whenever we want to, which is fantastic. We're now able to run analytics and allow our users to see how they're doing with their KPIs, how they're performing, how their suppliers are performing, what information is missing, and that's the power of a digital twin.
Thank you, Sanj. It's great to see the infrastructure digital twin in action. It's been a pivotal year, some would even say a transformational year, when it comes to the collaboration for our entire industry. It gives us a chance to reimagine how we would work together, and more importantly, how our users work together. It allows us to see how our technology is making a positive impact in our users' lives. Let me introduce you to iTwin Design Review. Design Review is a web-based capability that enables you to review design models with ease. It is open when it comes to source files. You can work with files from Bentley, Revit, Navisworks, Aviva, SmartPlant, IFCs, or Tekla, any format, you name it. Once the models are loaded, you can begin collaborating with all your peers in real time to view project status, identify issues, start solving real-world problems. Everything is web-based. As a user, you can log in anywhere using your web browser. Any information that is added from any user, anywhere, persists in the iTwin, making collaboration simple. With real-time chat, issue resolution, model comparison, clash detection, save views, markup, we've optimized the user experience for communicating about the problems that need to be resolved. In addition to identifying design issues and clashes, you can also perform data quality checks. These automated checks help identify inconsistent data structures and naming conventions, which will help you keep your project well structured and enable data analytics. As Peter Drucker stated, if you can't measure it, you can't improve it. Having structured data is what feeds the iTwin Design Insights, where you can define key performance indicators such as cost, schedule, risk factors, and carbon footprint. When a design is updated, the changes can be visualized from a comparison dashboard. Here you can see trend lines and make informed decisions based on the data. In addition to these out-of-the-box reports, we see an increased use of Microsoft Power BI by our users. In response, we've created data connectors so that the digital twin data can flow into Power BI and integrate with enterprise BI reports. In addition to the Power BI integration, we're also excited to announce that iTwin Design Review is now integrated with Microsoft Teams. The use of Teams is accelerated dramatically, and this integration brings iTwin functionality directly into the team experience. So now with a few clicks, you can add iTwin tab, making it easier than ever to access digital twin models. This opens up digital twins to non-technical users beyond engineering, helping them correlate and make sense of complex data in an interactive visual medium. We've seen the power of iTwin, a web service that enables teams to optimize collaboration. Now let's look at how our users are using the same technology to bring design to life during the construction phase. Now let's look at how our users are using the same technology to bring the design to life during the construction phase. To do this effectively, our users love to communicate a great story. A story that explains how the design is going to be built over time. A story that clearly explains all the materials, labor, and equipment that are needed, both when and where. A great project is not only one that delivers on time and on budget, but one that is delivered safely with minimal risk to the workforce. Today, contractors all over the world are harnessing the power of digital twin with Synchro 4D to deliver projects on time and on budget. With Synchro, design models are rendered according to the construction schedule, creating an intuitive visual medium for understanding and planning a construction project. Now, with a construction iTwin enabled, it provides the same ability to track issues and monitor changes as we saw with the iTwin Design Review. Users can collaborate real-time from anywhere, including from the field. With a construction digital twin, information can be updated in real time, allowing team members not only to plan construction, but also track progress in real time. With the information available on the web, it's also available from mobile devices, allowing users to update status, log observations, and create daily logs. This information from the field is synchronized with the construction digital twin. To plan a project, users import the design models and break those models into smaller sections based on how they want to approach the work. Splitting a design model calculates quantities, making it possible to calculate duration and daily work planning. The result is detailed visualization blocked by real schedules in real quantities, all visible and available via an easy-to-use web interface or as a high-quality animated video. Now on this front, we're excited to announce a new development of a new graphic pipeline that will take 4D animations in LumenRT, where users can augment the rendering with people, cars, plants, realistic environments, and high-quality materials. Not only that, but the experience is real-time rendering. No need to wait hours or days for rendering. And the quality is absolutely stunning. What if you don't have an engineering model or a construction digital twin? How can you create a digital twin from an existing asset? Let's take a bridge inspection as an example. Today's bridge inspection requires expensive equipment, involves high safety risk, takes significant time, and carries a high cost. In most cases, there's no digital history of the bridge. Some of our most advanced users are reimagining inspection through the lens of a digital twin. In Minnesota, the engineering firm Collins is leading the effort, fundamentally changing how infrastructure is maintained over time. With the real drone capture, it is possible for them to experience a virtual bridge in full detail as if they were actually at the bridge. The difference is they don't need a machine, safety harness, or a car to get there. And they don't need to close the bridge to perform the inspection. They are looking to do the whole inspection remotely from anywhere. Here you can see an amazing level of detail that can be experienced in mixed reality. The user can observe an issue, a defect, and mark it up with natural hand gestures. Take a measurement and fill out a form with their voice. The inspection information is then synchronized with the digital twin, where the results are visible in the web browser. The full history of issues now time-stamped and logged for future use. And that's not all. Using machine learning, we can now identify common defects automatically. Here you can see cracks being identified and colored. These can be validated and checked with the browser, phone, or HoloLens. For Collins, everything persists in the digital twin: the history of the asset, its condition over time, the historical record, 3D scans over time. Now we're going to shift focus to operating assets and talk about how our users from leading organizations in the plant industry are benefiting from digital twins. And for that, I'd like to introduce you to Maureen from our plant site team.
A process and instrumentation drawing, P&ID, is an important document. It is a blueprint of every process and power plant and comes in a variety of quality, symbol palettes, and overall complexity. Access to an up-to-date P&ID ensures safety of personnel and assists engineers in understanding the plant's operations. These documents, typically stored in vaults, require workers to physically retrieve them. This is not only time-consuming but also makes tracking changes difficult and error-prone. To solve this, alongside our reality data solutions, we have developed powerful AI and machine learning tools to extract meaning and understanding from these analog documents. While many companies are currently spending days having humans painstakingly recreate each raw document in a design application to make them intelligent, our approach here completes this task in mere minutes. This revolutionary patented technology makes the benefits of a digital twin immediately accessible to existing plants and unlocks latent value for our users. By integrating this output with PlantSight and AssetWise, we provide owners and operators a solution to efficiently realize the digital twin, empowering them and their teams to make informed decisions and take corrective action. Now let's shift gears and take a moment to look at industrial digital twins in the engineering phase. In any project, the cost and risk of an undetected design flaw increases based on where we are in the project's life cycle. Easy and democratized access to up-to-date information is the bedrock of efficient project delivery. Our users, like the one designing this section of a floating production system, are already telling us that PlantSight has improved design collaboration between the traditionally siloed teams. Now all of the stakeholders have the same view of the digital twin, leading to faster and higher quality 3D designs. These models are then being used for handover between engineering and operations, shaving weeks off delivery schedules and bringing higher returns on investment. Issues can be identified in real scale with the HoloLens and verified in the browser. The same data is synchronized between both the environments. Users are already reporting that collaboration with this immersive experience is enabling them to understand their design from a human-centered perspective. With issue management integrated into our desktop, mobile, web, and mixed reality applications, you no longer have to pass files and notes around in emails. All design decisions are electronically captured, ensuring that you not only have a timeline of change for engineering data, but also a complete audit trail of why those changes were made. With our digital twin capabilities, we have taken the suspense out of the design process, ensuring your heart skips a beat only when you see your amazing designs come to life.
Thanks, Maureen, for sharing some of the latest digital twin capabilities that are exciting our users that are operating large plants around the world. I really hope what you've seen today excites you and that you are inspired by the larger picture and are as fascinated as I am with the details of building digital twins for our world's infrastructure. I want to thank you for taking time out of your day to explore some of the most interesting applications of digital twins today, and to see for yourself the huge potential this technology has to offer. This was just a glimpse into some of the exciting technology in use today and what can be achieved with a digital twin. I hope this lifecycle showcase of digital twins help you see the changing paradigm of the digital transformation in digital twins.